morning, everyone. I am going to talk today about some of the things about sunflower production. So let's get started with the program. The first thing I would like to talk about is kind of setting the stage of what kind of productivity we have in North Dakota. So I know we have some audience from not out of North Dakota, but the trends that I'm going to discuss have also bearing on other areas of the United States. So what I have here is on the bottom the year, and then I have dots, the green dots, indicating the yield that was reported by the Statistical Service for non-oil sunflower, so this confection sunflower, and the yields are expressed in pounds per acre. And we can put a regression line to that one. And the good thing to notice is that last year we had the highest yield ever. And based on the regression analysis, we see that for non-oil sunflower would expect about a 13.5 pounds increase per year. If we do the same for the oil sunflower, we see that the increase per year would be about 11.7 pounds. And if we use the regression analysis and look at a prediction for the 2023 season, we would anticipate that based on that trend line, we would get in North Dakota on average 1,636 pounds per acre. And this is all based on average yield across the state. So the next slide, I'm looking at comparing the non-oil yield in pounds per acre and the oil yield. And as you can see, in North Dakota, sometimes the non-oil is lower than the oil. And last year, actually, the non-oil, the confection, was higher than the oil. But if we look at those trends over time, the non-oil over this whole period from 1965 till the last year is slightly lower than the oil productivity, but they are comparable. And as you can see, the dots represent the yield potential during a specific year. Now, the next analysis I would like to do is looking at some of the data generated by the USDA breeders. Now, the timeline is slightly different. It is going from 1995 up to last year. And the numbers in green are the numbers that you already seen for the oil sunflower. The blue dots are the numbers for the US breeder. So if you are looking at those two, you see that the trends are about the same. There is an increase in yield, both in the trials from the breeder, and this is the hybrids available to the public. It is not the breeding program. So we see these two trends, but we see there is a yield gap between the two. And if you look at the difference in yield, we see that the reported yield based on the period from 95 to last year was about close to 1,500 pounds per acre on average for North Dakota growers. But in that trial, we were able to get about 2,600 pounds. Now that gives us what I call a yield gap. So there is a potential yield based on the genetics. And then there are all factors in the field that may drag that down. So we may assume that in the breeder area where the land is uniform, all the management factors are optimal, that those fields give a representative yield what is possible under the given environmental conditions year by year. So we see for last year, there was about a 1,100 pound difference. So how can we close that yield gap? So there are a couple of things we're going to discuss. Water availability, of course, makes a big difference in the yield potential of the crop. We cannot control that necessarily, only if you have irrigation. Last year, we were kind of lucky that we started off with kind of a wet early season. The soil was recharged, there was enough moisture, and we ended up with very nice yields. Hybrid selection, planting time is important, tillage, seedbed preparation, plant population, fertility, and then, of course, weed control, and we need to control the diseases and insect. And, of course, we need to also think about bird control. So today, I'm just going to only talk about water availability, planting time, hybrid selection, and population. Other speakers will cover some of the other topics. So let's talk a little bit about water availability, as that is a major point. So we can assume that about 1 inch of water can produce 140 pounds of yield, but we need about 5 inches of moisture to get the plant established and into that reproductive phase. So I would like to use an example from Carrington, where we got last year from May to September close to 13 inches of moisture. Now let's assume there was 6 inches stored in the groundwater, in the ground, which would give us available 18.8 inches total. We have to subtract that 5 inches for the vegetative growth. So for reproductive phase, there will be about close to 14 inches. And we multiply that out with 140, we come to about a predictive yield of 1932, and actually yield was 2,500. So it just shows that there is a quick way, dirty way to calculate what the yield potential is. The other factor that is really important is also the planting time. So this is a graph from Carrington, but this would also be valid for most of North Dakota. If we start planting early in the season, there might be a little bit of a lower yield. The yield is expressed of the highest possible yield in the environments. So the highest yield was obtained in that period between 19th of May to the 29th of May. So it is important to get that crop planted early enough so that there is a long growing season possible for that crop to utilize the sunlight. The problem with late planting is that typically the oil is the last thing that is put down into the seed. So if we are late planting, we tend to see that oil content is lower. Also, there are chances for late season frost, and that can interfere with that seed set and oil deposition, and even the plant may not reach physiological maturity. So it is very important to get the planting date as early as possible to maximize yield. The second factor for yield is, of course, the hybrid selection. I already indicated that there is a big yield gap between the genetic potential that is available on the market and what farmers produce. However, it remains important to select a hybrid that is the best yielding in your environment. So we, of course, have oil type and non-oil type. We have different types of oil that we can select from and herbicide type. We can find some of the hybrid selection information for North Dakota in the variety trials. The resources will be available for you to kind of go into detail. This graph here is showing the hybrid yield that was obtained by Dr. Brent Hulke in his breeding trials. These are commercial available yields. And what I wanted to point out is that I kind of ranked them from the lowest in the trial to the highest. So we see that there is a group of very high yielding genetics available. But as oil is sunflower is an oil crop, we also need to look at sunflower oil. So here I have the oil percent on the left. And again, there is quite a bit of variability between the hybrids, what that genetic potential might be. However, what is the trick is, of course, to get a variety, a hybrid that has both high yield and on the right high oil in the blue line. So for instance, the highest yielding is a little bit lower in oil percentage, and we have a few that are a little bit lower yielding but higher oil. But the important thing is that we need to select a high yielding hybrid and high oil content in order to maximize our economic benefit from the field. We can also use another tool. This is somewhat new. It is a variety tool selection available at NDSU. And what that does is we can go to that site, select, for instance, sunflower oil. I select the oil for Carrington, and then it brings up a graph where it gives you the data for the variety, the plant height, days to maturity, and of course, yield. But I also would like to show you that there is an opportunity to chart the information. And I pulled down here a chart, and I was interested in comparing two hybrids to see how they have done over time. So here we are comparing the yield of variety B with variety A, and we see that B is higher yielding for the past year. Then if we look at the previous year, we see it was also higher yielding, and 2 years back, it was also high yielding. So here we can compare quickly, looking at a graph, the differences between some of the hybrids, and you can select some of the hybrids that you want to look at. Now I want to transition to the plant population. and yield. So the National Sunflower Association has always a survey every other year. That will be this year again. And the field surveyors go out and record many things. And one of the things they do is to estimate yield. So here on the bottom, you see there is a factor of 2,450 pounds as a starting point for yield. And then there are factors that are based on plant population, head diameter, seed size, good seed, center seed, and bird damage, which then results into an estimated yield. This has been used for many years, and I will show you some of the data. So what are we kind of doing is we counting the plants per acre, and then based on the per acre, we will have a multiplier factor that goes into the formula. So I'm just highlighting here the number that is going to be important for us to remember that we are aiming at 20,000 plants per acre, and that would give us a factor, a multiplier in 1, meaning that if it is a 1, that we are kind of optimizing on average that yield. If we have higher yields, that multiplier is a little higher, but then also the head diameter is lower. Second is measuring the head diameter. And again, we have some factors. So we had the head diameter and the multiplying factor in green. I will highlight just the one that gives you the number 1 multiplier, which is going to be the 8 diameter head. So that those are the two multiplying for the plant population and the head. The second one is the seed fill. What we do, we take a wedge out of the head, then we take the seeds out, but we should not take the seed out of the center, but kind of in the outside. Then we take 100 seeds and squeeze the seed and see if it's filled. And we take the percent of the seeds that are filled, but also we observe the seed size. And if you look at the seed size, then we have also a factor indicated here in yellow for the multiplication, and the medium has the width and the length indicated in millimeters, and the correction factor is 1. So the last thing to measure is the center of the plant. Typically, we see that the center does not completely fill, and then there are multiplication factors. So if 1 inch is not filled, we multiply by 0.975, or by 2 inches not filled by 0.95, and if there is a hole in the center by 0.90. But we can also, depending on the measurement, interpret how much the factor will be. The last thing to observe is also the bird damage. So sometimes it is bird damage, but it can also be the rubbing of the different heads against other plant parts of the neighboring plants. So those we have to estimate what the yield difference is in percent. So just a quick example, if we look at 13,000 plants, our multiplier would be 0.66. If we have 8.2 inches in diameter, our multiplier would be 1.03. We start with the example of 20, or the calculating number 2450, and we then get also a number for bird damage. So if you anticipate that there is, like, say, 2% damage, then the factor you use is 0.98. That is kind of the number of good seeds in that head. And then we get a yield of 1750 estimated. So the next thing that farmers are interested in is which is the most limiting factor. So the teams go out and score which of the factors is the most limiting. And in this case, I'm going to focus a little bit on plant spacing within the row. So plant spacing within the row, if it is a very wide spacing, we are missing one of the heads, and therefore we can anticipate a lower yield. So in this graph, I look at a lot of data from 2011 to 2021, and I look here on the left, the percent fields that were surveyed which had an issue with plant spacing. So you can see overall, on average, we had close to about 17% of the fields had an issue with plant spacing. So plant spacing is very important. And if the spacing is not correct, we are losing yield. So in this graph, we are looking here at the average yield obtained in those fields. And these are hundreds of fields. So the yields in pounds per acre, if there's no issue, the green bar reflects the yield potential. With plant spacing, as you can see, there is definitely a significant yield reduction occurring in that particular field. Therefore, plant spacing is something we need to consider and try to address where possible. So how can we kind of adjust the plant spacing? Well, of course, we need to consider the soil moisture. Poor soil conditions at planting can give us poor emergence. Sometimes with high rain, we can get crusting. With high temperatures and shallow placement of the seed, we might be soil drying. We have maybe insects in the soil. Maybe the planter was not adjusted properly. And we might have poor seed quality. All those factors play a role in the establishment of the plants. So if I'm looking here at this graph, I'm comparing two things. First, on the green is plants per acre times 10. So we multiply this number 1800 by 10. So that will be 18,000 plants. And then the yield is indicated in pounds per acre. So if you look at this data from North Dakota from 2009 to 2019, and I'm looking just at the mean value, you can see that the value of the plants per acre is very closely related in North Dakota with the pounds obtained. So in other words, if we have about 17,000 plants per acre, we have been getting close to 1,700 pounds of yield. So why is that important? Well, plants per acre on the bottom here, this is data from 2 years ago, plants per acre and yield. And we can see that there is a relationship with more plants per acre gives you more yield. So important to have the right population as well as the distribution. So here is a trial where we're looking at plants per acre going from very low to pretty high. And as you look at the column for yield, we go from a lower yield, increasing the yield, and we are targeting having 20,000 plants per acre. But as I showed in the previous slide, North Dakota has not obtained that level of plant population in all the observations we have done. So my conclusion is we have been too low in established plants in North Dakota and giving up some yield. However, we can also see that when we plant more plants per acre, that the head size goes from 11 with low population to about that 8. The last factor that is measured is the head moisture, and that has to do with harvesting. Because if we are looking at a big head, it will take a long time for harvesting that head. So the lesson is we need to get the plant population at the right level, about 20,000 plants, to maximize yield. So we have a few factors to consider: water management, hybrid selection, time in planting, and then optimum population and distribution.